So this is a quick review of inverse functions. So if I'm talking about inverse functions, I assume you know what functions are. If you could use a review on that, I do have a review video on just functions. So I'm just going to get right into it. So what is an inverse function? So if f is a function that maps x to y, then the inverse of f maps y to x. So it kind of like flips your x and y coordinates. So not all functions have inverses. Only functions that are one-to-one functions have inverses. So first of all, just as a quick review, so what was a function? So I said in a previous video on functions that functions are just a special type of relation where each input has exactly one output. So a one-to-one function, this is a special type of function. This is a function where every element of the domain maps to exactly one element in the range. Now, I think the easiest way to explain what I'm talking about with these relationships is actually with pictures. So I talked about this in a different review video, and I'll just review it here. So in this case, okay, so check this out. So with a function, you always have a domain and a range. With any relation, you have a domain and range. So a domain are your inputs, your range are your outputs. And so this is describing that relationship. So notice here, I have three different elements, different inputs in my domain, and they go to three different elements in the range. So this is a one-to-one function versus this one here. So I have these two elements. They are each going to the same output. So a function has each input going to exactly one output. But again, a one-to-one function is each element of the domain goes to exactly one element in the range. So the issue here is because two different elements in the domain goes to the same thing in the range, this is not one-to-one. So this is a function, but is not a one-to-one function. So just to be clear, this is a function and it is a one-to-one function. Versus this situation here, so look what we have here. I have one thing in the domain going to two different things in the range. So again, just to review, you need each input has exactly one output, and here you see my input has two different outputs. So this one here, this is not a function. So in a previous video, a review video, I talked about these situations, but in this video, we are specifically interested in this situation here, just to be clear. Now, also previously, I had talked about the vertical line test. So this is a way to tell whether or not a graph represents a function. So this says if any vertical line passes through a graph more than once, then the graph is not a function. So when we talk about one-to-one functions, we have the horizontal line test. And this says if any horizontal line passes through a graph more than once, then the graph is not one-to-one. So now we have two different tests here. So for instance, if I look at A here, okay, so the vertical line test would say that this is definitely a function. And so once you know whether something is a function or not, then you can test whether it is one-to-one. So I got rid of those lines, and now I'm going to draw horizontal lines. And you can see here, my horizontal lines intersect the function more than once. So this would be a function, but not a one-to-one function. Versus this next one, so here, this is definitely a function, but also, so if I get rid of those lines, it only intersects once. So this is also one-to-one. Now, if we do that again with, say, like C here, so here's the thing. So this is clearly not a function. And so once it's not a function, you don't have to go any farther. It doesn't matter. It's not one-to-one. So one-to-one is a label for functions. So if it's not a function, you're done. What about D? So D is a function, but is it one-to-one? It's definitely not one-to-one, right? Because if I draw a line this way, it intersects here. So this is not one-to-one. Okay, so continuing on, so I've got E here. So this one passes the vertical line test. So this is definitely a function. And then also, if I go this way, it's also one-to-one. And the same can be said for f. So you can see that I can draw these vertical lines, and then if I draw these horizontal lines, so this is both a function and it is 1 to 1. Okay, so this is important because only 1-to-1 functions have inverses. So once we know something is 1-to-1, then we can talk about its inverse. So another way that I could ask this, just to kind of warm up now the idea of an inverse, is I could say which of the following represents functions and 1-to-1 functions. Okay, so in this case, I want to think about now these more direct mappings. So I could think about, here are my inputs, 3, 7, and -2, and where do they go? They go to 4, 2, and 5. So this is indeed a 1-to-1 function because each input goes to exactly one output. And so because this is a 1-to-1 function, just to also kind of introduce this idea, the inverse then in this case would be 4, 3, 2, 7, and 5, -2. So once we have a 1-to-1 function, this is like the idea of what we're trying to do. We flip-flop those coordinates. So let's take a look at these other two situations then. So here for my inputs are 4, -1, and 7. And what are my outputs? My outputs are -2 and -3. I'm not going to write down -2 again. So I have 4 goes to -2, -1 goes to -3, and 7 goes to -2. So this would be a function, but it is not 1-to-1, so it's just a function. Versus if I have 5, 6, and 5, and then 2, 3, and 7, 5 goes to 2, 6 goes to 3, and 5 goes to 7, so this would be not a function. So again, this is like the type of relationship that we're thinking about. So we've seen then that the idea of finding an inverse, if we have an inverse, it is just this idea of I just flip-flop my coordinates. So how would I do that then if I have, say, like a whole equation? Well, in this next set of exercises, we can just take for granted that these are all 1-to-1 functions. And so to find the inverse, so it's actually a very similar idea. So to find the inverse, the first thing that you're going to want to do is you're going to want to rewrite the function with x and y. And then you're going to want to switch the x and y in the equation so that this becomes x equals 3y minus 2. And after that, then you want to solve for y. So to solve for y, I'm going to go ahead and add 2 to both sides. So I have 3y equals x plus 2. And then I'm going to divide each part by 3. So now I have y equals, I'm going to rewrite this as 1/3 x plus 2/3. So the final thing that you want to do is you want to use this inverse notation. So this f -1, that's what indicates that we have an inverse. So I'm going to restate this as f inverse, and then I'm just going to restate the same equation. So that's how you find an inverse for a general equation. Okay, so let's try that with this next one. So I strongly recommend, let's do this one together. So let's do this in pieces, and I strongly recommend that you pause the video just when I tell you to. So what I want you to do next is I want you to flip the x and y's and then see if you can solve for y like we did before. So pause here, give it a try. So I'm going to flip my x and my y's. So this will be 4y minus 2. So I can go ahead and add the 2 to both sides. So I get 4y equals x plus 2. And I'm going to divide each part by 4. So I have y equals 1/4x plus 1/2. And so then this will be f inverse equals 1/4x plus 1/2. So there's my inverse function. So again, you want to just have that inverse notation. And then what that does is it makes it really clear what the relationship between this and this function are. They are inverses. Okay, so I have 3 more examples like this of just kind of kooky things that can happen when you're trying to find inverses. So I strongly recommend that you pause each one of these and just see if you can do them and then hit play when you're ready. All right, so I'm going to rewrite this as y equals x cubed, and then I'll flip my x and my y. And so to solve for y in this case, so I have to get rid of this cube. So what I'm going to do is I'm going to take the cube root of each side. And so what I will get is that, let's see, this is g, not f in this case. So g inverse will be equal to the cube root of x. So that would be the inverse in that case. Okay, so I have another one here. So this is kind of an interesting one. So f of x equals negative 5 over x minus 2. So you can pause here and then give this a try when you're ready. Okay, so I have y equals negative 5 over x minus 2. So this one's kind of interesting. So let's see, I'm going to flip my x and my y. Okay, so in this case, I need to get the y by itself, but I have this fraction. So in general, when you have a fraction, what we want to do is to get rid of the fraction, we just multiply by the denominator. So you have to do it on both sides to maintain equality. So what this is going to turn into then is I have x times y minus 2. So these y minus 2's will cancel out, and I'm just left with negative 5. So now I want to get y by itself. So to get y by itself, I'm going to divide out the x. So I'll continue this over here. So this becomes y minus 2 equals negative 5 over x. And now I can see that to finish this, so I can just add the 2 to both sides. So my inverse in this case will be negative 5 over x plus 2. So that'll be my inverse. Okay, and finally, so this last one's kind of interesting, so I'll do it with you guys. So let's go ahead and do y equals the square root of x plus 2. So we go ahead and we flip our x and our y so that we can find the inverse. And then I have to solve for y. So what I'm going to do is I am going to subtract the 2. So I have the square root of y equals x minus 2. So to get rid of the square root, what I need to do is I need to square both sides. But now here's where the interesting thing happens that we have to kind of think about. So x minus 2 squared, this is a parabola. Parabolas look like this. So parabolas are not one-to-one, right? Because they would not pass the horizontal line test. And so what makes this particular problem interesting is that we have to be careful then when we state the inverse. It's not that we found the wrong inverse, it's that we need to make one other adjustment to it. So the thing to think about is, what is the domain of g of x? Well, the domain is, so if I have the square root of x, so x has to be greater than or equal to 0. So all of the entries in this, because when we talk about functions, you can't have imaginary numbers. So the entries here have to be greater than or equal to 0. And so I need to add that little note onto this particular inverse. So here, I need that my x has to be greater than, well, not actually 0 in this case. I wrote 0, but actually we need to think about this for a second. So what is so where would this 0 out? So this function will equal 0 when x equals 2. So at that bottoming out point where this equals 0, that's where I need this to be greater than 0. So we do have to make just a slight adjustment to that. And you can also figure that out, by the way. So another way you could think about this is, so think about what happens at 0. So if I plug 0 into this equation here, I get square root of 0 plus 2. So this will be the point 0, 2. So remember, we said for the inverse that you flip-flop the coordinate, right, to get the inverse. So if this was the situation where everything has to be greater than this point, then I flip-flop it, and that's why it's x is greater than or equal to 2 for the inverse, because I flipped that coordinate. Okay, so I do try to keep these review videos on the shorter side, but you might feel like at this point that you need to see more examples or do more examples to master the material. So if that's the case, don't worry, I've got you. So every review video comes with a practice problem set. So the practice problems include a PDF of problems, an answer key, and then also worked out video solutions. So you can decide if you need to see more examples, you can do that, or you can practice or whatever. So you can go to divideandconquermath.com and go to the review section. So remember, you can't learn math though by watching a ton of YouTube videos. At some point you do have to practice it if you want to master the skill. So use these other materials that I have for you, use them in the way that makes the most sense so that you can actually master this. And by the way, my review series has many other topics in it. So each topic includes a refresher video, practice problems, an answer key, all that good stuff, worked out video solutions. So it's all free. Just go to divideandconquermath.com, go to the review section, and you'll find everything there. But otherwise, I'm going to leave it at that, and I hope to see you in another video. Peace.